In this video, we'll discuss rhombi and squares. Now, before we've talked about parallelograms and rectangles, now a rhombus is a very special parallelogram in which all the four sides are congruent. This causes some special things to happen with the diagonals. For example, they'll be perpendicular, they will bisect each other, and they will also form angle bisectors to each of the major angles. By creating this, you end up with four congruent right triangles inside the rhombus, and you can almost see them here in how they line up. So if I knew that one side, say side JK, had a length of 10, I would know that all four sides would have a length of 10. If I was later told that the length of diagonal JL was 16, because I know that the diagonals bisect each other, I would know that JN and NL would both have to have a length of 8. Now, recognizing that they're also perpendicular, I would see that I have a right triangle here, and I can use the Pythagorean theorem to help me find the length of KN. That would tell me that KN would have to be 6, so NM would also have to be 6, and the length of KM would have to equal 12. So the diagonals are not necessarily equal to each other, but they bisect each other and are perpendicular. Now, when we talk about the angles, we still have the properties of a parallelogram. So we know that diagonal angles are still congruent, and consecutive angles are going to still be equal to or sum to 180 degrees. They're going to be supplementary. So if I knew angle A was 86, angle D would have to be 86, and then the measure of angle B and angle C would both have to be 94 degrees. So those properties still hold, and that's the same for all parallelograms. But when I draw in my diagonals, what I recognize is that I have this angle bisector. So if I take those same measurements of 86 and 94, they're now being bisected. In other words, those measures are going to be cut in half. So where it was 86 for the entire angle, it will be 43 degrees for each of those bisected angles for both at BAE and EAC and their corresponding diagonal angles, as well as it's going to be 47 degrees for each of the bisected angles for angle B and angle C. And you can see then how these triangles will match up to have the fact that it's four congruent right triangles. Now, the fourth special quadrilateral we'll talk about is the square. It's a special parallelogram in which all sides are congruent and it has four right angles. By having those two features, we know that a square is a combination of both a rectangle and a rhombus. So any feature of a rectangle and a rhombus are both true for the square. That's why you have all sides congruent, the diagonals will be perpendicular, bisect each other, and form all the perpendicular bisectors and the angle bisectors. So once I know one side is 8, I know all four sides are 8. And if I draw in my diagonals, I see that I end up with isosceles right triangles. That's the 45, 45, 90 triangle. And I can use that to help me find each of those smaller diagonals and the larger diagonal. So I could go either way. But let's look at the small right triangle that's formed here. I don't know the length of MR or RN, but I know that their lengths are congruent, so I could use Pythagorean theorem, and if one side is x, then the other leg also has to be x on my right triangle. So I have 2x squared equals 64. Divide by 2 and take the square root. I want to simplify my square root and end up with 4 to the square root of 2. So all four of those smaller diagonals are 4 to the square root of 2, which also means that the length of the entire diagonal will be 8 to the square root of 2. Now, if I also think about the fact that I can talk about the angles, I have a 90-degree angle that's being bisected because the diagonals are angle bisectors just like before. So that means each of those angles will be 45 degrees, and since it's isosceles, I know that the other corresponding angles within each of the isosceles triangles have to be 45 degrees, so I end up with four isosceles right triangles, all of them having the 45-degree angle when they're formed by the bisector. So this tells me that I can start to classify specific properties and attributes to the different shapes. I start with the idea of a quadrilateral. There are lots of different types of quadrilaterals, but within there I have specialized groups. For example, I have parallelograms, and they have very specific characteristics. Within the parallelograms, I can get even more specialized. For example, I have a special group called rectangles where we have the 90-degree angles. I have another group that's specialized of rhombi where all the sides are congruent. This doesn't have to be true for all parallelograms, but it is for a specialized group. And even more so, there's this super special group that overlaps of the rectangle and rhombus called the square, with the 4 right angles and the 4 congruent sides. Another way you'll sometimes see this is through a tree diagram, where we start off with parallelograms. They can split off into 2 different groups, the rectangle or the rhombus, but then there's always this ability for the 2 to come back together to form the square. So we want to think about some of the relationships that may exist. For example, what quadrilaterals have congruent opposite sides? Well, that's a feature of a parallelogram, and if it's a feature of a parallelogram, it's true for the parallelogram, the rectangle, the rhombus, and the square. How about the idea of quadrilaterals having 4 right angles? Well, that's something that's special for the rectangle. It's not true necessarily for all parallelograms, but if it's true for all rectangles, it's true for all squares as well. Does there exist a rhombus that is not a parallelogram? Well, if I look at my Venn diagram, I can see here's my oval with the rhombi. They are all within my parallelogram. So it's not possible to make a rhombus that's not a parallelogram, because by definition, all rhombi are specialized parallelograms with all sides congruent. Then can a square be a rectangle but not a rhombus? Well, if I think about with the parallelogram, a square is a specialized rectangle, but it's specialized in the fact that all 4 sides have to be congruent, and that's a feature that makes it a rhombus as well. So no, it's not possible to be just a rectangle but not a rhombus to become a square.